3M, Unit 3, Lesson 3, a little bit more algebra to just help us with some graphing things. So the first question says, solve for A if you know some information. And A is how steep or how wide a parabola can appear. You know for A that if it's negative, your parabola is upside down. If it's a fraction between 0 and 1, it's going to be a wide one. And if A is a number larger than 1 or smaller than -1, it's going to be a skinny parabola. So this is what we want to determine. We know a few things already. We know the x-intercepts from the form, which is factored form. So we know these 2 points, when y is 0, x would be, from that bracket, -2, and from the second bracket, -1. So we already know a fair deal. We were also given a point. They gave it to us in kind of a strange way, but we knew the point that when x is 2, y is 36. So we could draw it and get an idea of what A is, but we're going to try today with no graph in front of us, see if we can determine A. So what I'm going to do is I'm going to substitute the point that I know into the equation. And the only thing I'll be left with that's unknown is A, and I should be able to solve for it. So be careful with these. The points are in order x, y. So my x value is going to be the 2, and my y will be the 36. So 36 goes where y is. I don't know A, trying to find it. X is 2, 2 plus 2, and 2 plus 1. So I put everything in where it belongs, and now I just have to tidy up. 36 equals A times, this bracket gives me 4, and the next bracket gives me 3. 36 equals A times, well, I'm going to multiply those two to get 12. And my last step would be to get rid of that 12, which is squished up to A, implying multiplication. To get rid of multiplication, we need to divide both sides by 12. Final answer, A equals 3. So this is an opening upwards, skinny parabola with x-intercepts -2 and -1. Second example. If we have a little bit trickier problem, we would do the same thing. This also tells us the x-intercepts. It's just that they're kind of ugly. But I really feel the practice is good for us. So when each one of those brackets is equal to 0, that gives us the possible zeros or x-intercepts. So for the first one, I'm going to do my work over to the right. When 3x plus 2 equals 0, I'm going to subtract 2 from both sides, and then I'm going to divide both sides by 3. I am writing less and less of my thought process here because you're getting more and more used to doing them. So one of my x-intercepts, if you care, is -2/3. The other x-intercept is when 2x subtract 1 is equal to 0. I'm going to add 1 to both sides and divide both sides by 2. X equals 1/2 is my other x-intercept. We were also told a point. They just wrote it separately again, but the point would be 2, -24. So I could get a sense of what this looks like by a super rough graph. I have an x-intercept of -2/3 and +1/2, and a point of 2, -24, way down here. So it appears that my parabola would open downwards. Let's see what the math shows. So for this equation, I'm going to substitute the point that I know so that I can solve for A. The point is 2, -24. Remember that they're in the order x, y. So the -24 is my y value, goes where y is. I want to solve for A. In the first bracket, I have 3 times 2, so I'm going to put another bracket instead of a times sign. And my second bracket is 2 times 2, subtract 1. And we have to be careful of order of operations. first bracket is 3 times 2, which is 6. And I'm showing every step so that we're careful. And the second bracket is 4. Subtract 1. Next line, I'm going to figure out each bracket. Order of operations would say finish your bracket if possible. 8. 4 subtract 1 is 3. My strategy would be to do the multiplication on the right side, get 24, so that my last step would be divide both sides by 24 to get the a by itself. Nicely, a is negative. 24 divided by 24 is negative 1. So the equation is really y equals negative, you could write your 1 or not, 3x plus 2, 2x minus 1, because I know the point 2, negative 24. Determine the equation of each of the following parabolas. All right, this one has two. Now I'm going to trust my eyes on a graph, which is not always a good idea, but I see some points that could be helpful. My two x-intercepts. So I know that when I have my x-intercepts, I can write it in factored form. I know that I have an a value that tells me whether it's right side up or upside down. I know that this one's going to be positive because it opens upwards, and it will tell me how steep or how wide it is. And we're going to use another point to solve for that. From my eyes, it appears that one of my x-intercepts is 4, 0. So I would write it in this form, x subtract 4. My other one appears to be negative 1.5. So in brackets, I do x plus 1.5. From the x-intercepts on my graph, remembering that the signs are opposite in the brackets. I am pretty confident that I know this point right here. The vertex I think I know, but I'm not sure. So I am going to substitute a point I am very comfortable with, which would be when x is 0, my y-intercept is negative 12. If you know a point, you can find your a value. My next line would be the negative 12 goes where the y is. I'm trying to solve for a. 0 is wherever x is, and I would substitute the values like that. I'm going to tidy up my brackets next. Negative 12 equals a times 0 subtract 4 is negative 4. 0 plus 1.5 is 1.5. I would like to do the multiplication first. Negative times a positive is a negative, and 4 times 1.5 is 6. I'm going to divide both sides by negative 6. And I say, yay me for coming up with such nice numbers. A equals negative 12 divided by negative 6 is positive 2. So my equation will be y equals 2. X subtract 4, x plus 1.5. Determine the equation of this guy. Again, pretty confident I've got the x-intercepts as 3 and negative 2. Whoops, I'm sorry, I need a 0 there. Negative 2, 0. So my equation is going to look like a stretch factor of x, x. And remember, if I have an x-intercept of 3, it's going to be x subtract 3. If I have an x-intercept of x is negative 2, it's going to be x positive 2. And I want to solve for y. I need a point. My point that I'm confident about is, again, the y-intercept. It's just easier to see things on those axes. But I like that point. It's 0, negative 6. When I substitute those values in, the negative 6 is y, solving for a, 0 for x. And it never hurts to remind ourselves, order x first, y second. All right, let's solve. Negative 6. 0 subtract 3 is negative 3. 0 plus 2 is 2. Isn't that nice? Zeros are nice. Negative 6 equals a times, and I'm going to multiply those two numbers, get negative 6. Divide both sides by negative 6, and I get 1. So my final equation would be y equals 1 times x subtract 3, x plus 2. You can write the 1 or not write the 1. Doesn't matter. Last one. We probably could write the equation of this in vertex form from our first unit, but we're focusing on factored form here. So I'm going to write the equation of this parabola using the x-intercept 0 and 4. And I want to find the a value, which I know is negative because it's upside down. So I know that my equation is going to look like y equals a times x. The one x-intercept is 4, so I would have x subtract 4 in the brackets. The other one is 0. Well, technically x subtract 0, although you never have to write that. I need another point in order to find my a. I'm going to substitute the point that I'm pretty confident about, which is the vertex. I know the vertex is in the middle, even though I can't see my grid very well. And I know the middle between 4 and 0 is 2. And this is where I was fairly confident that that highest point is at 20. So substituting for x and y, I have 2 and 20. My y value is 20. My x value is 2. And some quick algebraic tidy up. 20 equals a times 2 subtract 4 is negative 2. 2 subtract 0 is 2. 20 equals a times negative 2 times positive 2 is negative 4. To get a by itself, we divide both sides by negative 4, which will give us negative 5. And I expected a negative because it's upside down. The scale is also very different vertically than it is horizontally, so it would be really difficult to determine that a value by looking at your graph. Y equals negative 5 times x subtract 4 times, I don't want to write x subtract 0, I'm just going to write x. And that is our final equation.